Hi, my name is Monica Sanchez, and today I'm going to explain you how to do this piece. Let me put it. How to do this piece in the simulating program for the CNC lathe, and it is the FANUC program. So yes, we are using DOSBox with the FANUC simulation program to do that piece. I have prepared these calculations. These are all the coordinates that the tool needs to pass through to get to the shape. These coordinates are not used like sequentially. Some of them are, but they are separated into different pieces, into different processes, because not all of them could be done using a single tool. So yes, it will take a long time to explain all of those, but in here I put the original drawing, the original sizes, measurements. I put where the points are, where our reference points are located. These are those in red, the ones that we're going to use, like this. And in here, we have all the measurements without all the lines from the other image. And yes, this is the starting point. This is this point, this point, this point. This corresponds to this both points. Here I put these points. These 2 points correspond to these coordinates. These 3 points correspond to these coordinates sequentially. This is the first one. X7, C minus 25 is the first one. Then the second one, like going up, is the one in the middle, and the last one is this one, that is the last one in here. Now it goes to a straight line. It does this one. The first one is the X9 the first one is the X12 C minus 42, and then we go to X9 C minus 45, because it does this. These 3 points, because they're really, really tiny, but they're important, are this one. This one is the first one, next one, last one. In here, I put all these 4 points. These ones are grouped in here, starting for X11.6 and finishing in also 11.6. And these two are this two. Now, what is the first step to build this? This piece is to know the total X and the total C for the billet. For this piece, or total, is going to be, remember, alt 91 to obtain the symbol. We write billet, or total. The one that I consider appropriate is X3013 and C90. You could ask why, because if we look closely, or maximum coordinate in X is 12.7 or 13, I think there was one. Well, no, 12.7 is the larger X coordinate. So we are not going to use that exact one. So I use X13 to avoid any mistakes. And for the C, the last coordinate is minus 70. And because we need a margin, we need some space to do the final cut. I'm going to use 90, just to have if we made a mistake, to have a lot of material. Now, as you remember, we're going to define the tools. We're going to define 3 tools. I think 3 will be enough. The one, now again, tool def, the tool, remember that I explained all of this. I explained all of this like these parameters in the video of the practice number 4. It's a longer, it's a longer video, but I explain. But in there are like all the parameters explained, but I'm going to explain them anyways. Now, what is the first thing that we need to do to start the code? We need to set our security parameters. Remember that we are using this as sequential numbers. They don't need to be like 1, 2, 3. Just need to be sequential. You can use one line can set 6 and one line can say 10 and one line can say 11. It'll read the same. It'll read sequentially because the numbers are sequential. So we're using n10 and we're going from 10 to 10. This is to avoid that if we need to change or to edit something when we have already finished the program, we can return and just add them. So we start with G21. This is to set that we are working in millimeters, and G39 is just a parameter that we will always use for the feed radio. It has to do with the RPMs and have the spindle spins. And then the next one is G28. In this, we're going to set the home positions for the tools, and we're going to set the relative positions of U0 and W0. This is to say, with this, we are telling the program, you're going to return to the positions U0 and W0 no matter where, in which point you are. It's always going to be 0, 0. Now, remember that the U corresponds to the x-axis, and the C corresponds to the W-axis. And remember that we are using x as the up and down coordinate, and we are using z for the horizontal coordinates. Now, N30, we are using M6 to set the tool that we're going to use. We are going to use the T1. T1 is already set. Yeah, I click F1, set tooling, and F1 is already set. The tool one is already set as the 14. That's the one that we're going to use. That's okay. So T1, and now in the next line, what is missing? We need to make the spindle actually spin. So we are using M03. M03 will make the spindle spin, like it is to turn on the spindle, and it will spin clockwise. M02 is to spin the spin, and M04 is to spin the spindle anti-clockwise, but it's the same. We don't need to worry about that. And we are setting the RPMs on 1200 RPMs. Now, we are setting our starting position where the tool starts with G00 because we are not in danger of hitting any part of the piece. G00 is a fast movement. G01 is the ones that we use when cutting, but right now we are not cutting, so it's okay. And we're using the same coordinates as these ones. So X13 and C19. I mean, no, C is 1 because we are setting it in the starting point, and 19 will be like far away from there. C1. Now in the next line, we are using a G71 we're using a G71. G71 is the roughing process. The roughing process is to make the tool do a lot of passes to obtain the points that we gave it in the code. G71 is to avoid to have missing pieces, missing material in our shape. If we don't use G71, we could have problems, like we can leave tiny dots in every now and then in the billet that in here will look like they are floating, but in real life, you know that they will fall. They will hit the spinning billet, and it can cause an accident. So let's avoid that by roughing all the surface. So G71, G71 has two lines. The first one will be U and R. In here, in U, we are gonna set we're going to set how much to cut for each pass. In this case, I'm going to put 0.1 because since it has more details, it can cause a conflict in the program. So to avoid problems, we are going to use 0.1. Actually, let's use 0.2. And PR as like is something like this. Is something about to know how much to retract when it's a cut. It's for safety. These are safety measurements. And now the N70. N70 is the other part of G71. And G70, we are using the starting point, the final point. The starting point is, I'm going to set it on, I just put 80 for printing something, but we need to put the starting where the code actually starts. Like, when do we start to cut? We're not gonna cut in the next line, or maybe we will, but it's just the starting point. And the Q, it is not possible to use the Q right now, to set the Q right now. So I'm just going to set it on to that 200. But the Q has to be edited at the end of the program because we are telling the program where to stop roughing, and we need to have the outline done to do so. And now the U01 and W01, 0.1, I'm sorry, are the roughing allowances. So when roughing, we need to place allowances because it is not as precise as finishing processes. So we have an allowance of 0.1. We are not going to have much problems because the piece is still simple, doesn't have much details that needs to be done with the roughing tool. So we're just going to set that for now. And now we're going to start our cutting processes on N80. And since we are using the roughing, we need to give it a starting position. So I'm going to give it the 11.7 as the X. And G01, let's use the 12.7, and C, let's use a 0.-1 to start cutting like a little bit inside of the piece. Remember that when we are using the roughing, we cannot simulate until we're done, because then we will have errors because the process isn't finished. So just to avoid any mistakes, any confusions, we are going to simulate until we are done, and then when we are done, we can correct the mistakes that we have, but once the roughing is secure. So as I said, since we are using the roughing process, we need to start with a single line of X, like where we set an X value. And yes, it's just something that the G71 requires. Now we're starting on the 12.7 C-1, because remembering here, CX 11.7 C0, that is our starting point. Like, we moves from here to here. We already did that one. Now we move from here to here. 12.7 C-1, and what we have here, 12.7 C-1. Now the next line, where do we want to move next? We want to move straight to this point, 12.7 C-6. Right now, we are not gonna do the slots, the groups, because it is necessarily another tool. So we're just gonna do like all the contour, like here. It is not really appreciated in here, but this has different measurements in X. So we're going to put every measurement of those. And it's N 100. We are going from G01, X 12.7. I mean, G01, we are moving. We said that we're moving to 12. We remain the same in X. We just move to C minus 6. That is actually minus 15 because we are moving to that side. So just minus 15 because we are adding all the material. Because we are not moving to this point, we're moving to this point. Because if we move to like just to this point, we are going to have to add another code for this. So we're just gonna do like we're just gonna go straight from here to here. And then when it's time to cut, we are just going to cut in the middle of here. So we go, if we don't write an X in the coordinates, it means that we're using the last one. So it's just like to avoid repetition, it is C minus 15 and now 110. We go G01, X9, C25. Let's see in here. We're going to X9. We're going to do this little inclination. We're going from here to here. It is not cutting a vital part of the piece. We are just cutting material. So we go from here to here, and we are right now located in X9C25 in here because it will be a little more difficult to start in here. So we're just gonna do that part with the other tool. So we are going from here to here. The next position is X12C minus 28. And 120 G01 X12C minus 28. Okay, it's all correct, and 130. From here, we're moving to C minus 42. Remember that we are using the same X. I made a mistake in here. It was 12 space C minus 28. Now we're using the same X, which is moving in the Z axis. Now it is 42. And from there, we need to do this inclination. That the coordinates are Gx9, C minus 45, and 140, G01, X9, C minus 45. Right now. And 150, we are doing, we're moving just to the side, just we're moving from here to here. The coordinates from there is X9C minus 55. So we are going to use G01 because we are still cutting. G9C minus 55, 107 and 60. We're moving from here just a little bit above. We are able to do this part with this tool because since it's a longer part, we're not in danger of cutting anything else. So we're just going to move to these coordinates that we already have in here. We can skip this part in the next code. So it's just x 10.5, 10.6, I'm sorry, T01, x 10.6, and now n 70, G01, x corresponds to 11.6, and c minus 56. That is the coordinates that we have in here. 11.6, c minus 56. Now, where do we go next? We are still moving in this same x-axis, so we're just going to move to 69 because we don't need to do any more grouping here. So we're just going to move to 69 and 180. Let's see if I put everything 180, G01. And the same x, just moving in the z-axis. I said it was 69. 69, and then n 190. For 190, we have the G01 because we're doing an inclination. X 10.6, that is a millimeter from the other x, and C minus 70. And now let's just move the tool a little bit above to avoid any collisions when the tool is returning to the initial point. So we're just going to move to x25. This is for the tool to like move up in here and to go like in a diagonal to the starting point. Now what do we need to do? We need to do we are all done with the outline. We can do the simulation right now, but we are just going to continue with the change of the tool. So now we're going in to 210. Right now we want to do the finishing process because remember that we left a allowance. Usually the finishing, the G70, we use it for when we're using in like it goes in the same pack. We use them together because the G71 leaves an allowance, and the G70 it sticks to the coordinates, to the exact coordinates, and leaves a smoother finish. So to change the tool, we need to stop the spindle. It is very important that the first step is to stop the spindle with M05. And now with N200 and 120, we do the same as we did in the first block. That is to set the security settings with G28, and we change the tool. We're choosing T2. Let's set T2 to be this one, the finishing tool. It was already set, so it's okay. That is the one that we already mentioned, that it is commonly used together with the roughing tool. In here, I'm going to specify that I use the finishing tool. I think it was number 14, but I think it was 15. Well, 14. This is to avoid any confusions if I put the program again, if I close it and open it again. And 240. And now the spindle can spin again. M03, S, speed 1200. Now let's do the finishing process with 250 G00 to set the tool just in the outside of the material. And now we can do the 160. We can do the G70 code. In here we put the starting point. The P represents the starting point, just as in the roughing process, and the Q starts the finishing process. So our Q is, I put the exact same Q in the last one. I didn't know what we were going to end it on 200. Well, yes, Q is 200. Now we are done with the finishing. Now we need to do the grooving parts. Now we have to do another tool change. And we are setting the same parameters that we already did. We are on 70, and we can just write the same as we wrote in here. M05 to stop the spindle, and 280 to set the G28, the starting points, U0, W0, U0, W0. Now, the setting of the tools, M06, I'm going to set it on the tool 3, and the tool 3 will be this tool. It was already set, so it is the 2mm grooving tool. We can use whatever grooving tool we want. I want to use this one. And we can let the spindle spin again. And 300 and is 1,200. And I'm just going to specify that I use the 2mm grooving. The 2mm grooving tool. Now, in this part, I'm not going to use a roughing cycle. Why? Because this part of the process involves like doing some cuts that are deep, and if we use the roughing tool, it's going to want to return to its initial point, and since it is deep in the piece, in the material, it will cut it will hit the material that we already finished, so we don't want that. That's why we are not going to use a roughing process, but it's okay because we're just going to do simple cuts because we leave it as simple in the code before. So where do we gonna start? We want to start here. In here, we're going to set our tool in this coordinates because are these ones. These coordinates correspond to this. So x10 c minus 9.5. So and 310. I'm not going to place an x right now because I just want to move diagonally. So I'm just gonna put minus 9.5. I'm just gonna put minus 9.5 to just move like from here to there. And 320 G01. I'm going to move x13. And now, right now we are here, like in here. What do we need to do? We cannot put the tool like down and cut straight to the side because the shape of our tool doesn't have a cutting edge on the sides. So we have to use the tool and we have to use G75. G75 is a process that allows the tool to go up and down like repeatedly like this for a range of lines that we set. So this G75 also has like the G71 has 2 lines of code. The R is the retrocess, like how much does it return or how much does it cut between each pass. And the next line for G75 is the X, C, and P. X is the finish point. In this case, we are going to use 10 and minus 8 in here. It's the finish point of where the rapid movement is going to stop, where the cut is going to stop. So we set on 10 and 8, and the P is the millimeters cutting, or the retrocess, the how much does it cut between each pass? How much does it move? We can also put the Q and F, but if we don't put them, the program takes like the default values, so we're just gonna leave it like that. It's just that these ones are necessary for the program to run, to do it properly. So we're finished with this one, so we can move to X25, just to make the tool up to not cut anything. And we are going to move to C minus 25. Why C minus 25? Because it is in here. Minus 25, remember? Now, minus 25. And we also move closer to the piece. It was 60. Now we are moving closer by moving to X13, and we all again are going to use G75, and we are going to use R1 as in the other part. How much are we going to cut? Now N 280, G75. Where do we want to stop? We want to stop in here. That's why we're going to use then X7 and C17. 17 because and that's why we stop in 8 in here too. It's because our tool, the measurements of our tool are 2 millimeters. So we have to stop a little bit. We have to stop 2 millimeters after. We have to stop 2 millimeters before our finish point. So if our finish point is 15, we want to use a Z of minus 17. And P is the same. Now we go up again, 100 and 219, X25 to avoid collision. Now we go to what's our next piece? It is in Z60. Our next group, it's in here. Now this group already, the size is already 2 millimeters, and our tool is already 2 millimeters, so we don't have to use the G75. So we're just gonna go straight down. So we're going to place our tool on C60 and 310 and X9. Yes, X9 because we are in here. 9. Do you see? 9. X9 and 320. 320, and now we move the... Oh, I forgot to put the G01 in here. Let me edit it. And here is C minus 60, G01, C minus 60, and in here too. G01, X minus 9. I mean X9, sorry. Now in the next one, we are using the X9, I mean the G01, because we are moving up but we are still in danger of cutting something in the movement because we are inside of the material. So just as a safety measurement, we are using G71 to be slower, and we can move to X25. Yes. Now the last part is just to do the final cut, as in the last piece. So we want to place our tool in here. If we want to do the piece to measure this, we have to add 2 millimeters. That are the ones that the grooming tool measure. So if our last point is 70, where do we want to set our tool? 72, minus 72. So we are already up, and now we go to N330, and we go to C G0. We can use G00. C minus 72, taking into account the millimeters of the grooving tool. And now we make our tool go down with G01. And we're going to put an X2. Why not 0? Because we are cutting and we are leaving a little bit of material for the piece not to just go like fall. We want it to be like still stick together, and so we can cut it manually with a tool or with our hands when the process is done. Now we move up again, 350 G01 X25, and since we are not doing the roughing process, so our tool doesn't go automatically goes to the starting point, we are going to do it manually. This is a measurement, safety measurement. So we go to 15 X15 C1, and with that we finish all the cuts in our process. Now I'm just gonna put 400, and we can finish as we stop the program, as we stop the spindle and the last sections. And 15 G28 U0 W0, just as a safety measurement, not necessarily necessary. And we start the program with M02. Now it's the moment of the true. We can simulate the program. We have all our tools set, and we start. This is the first inclination. Never spotted the error. It was because I put it in here. In here there was an X instead of a 25. So let's just simulate again. It should be fine by now. It is the first inclination, goes all the way from there. It looks like that right now because remember that we didn't do any cuts with this tool. We didn't do any vertical cuts with this tool. That's the finishing part. Remove the excess materials, and now we change to the grooving tool. It cuts the first part with G75. Let's do where's the error in that part, because it didn't have to go that way. I already spotted the error in here. It was because I didn't put any measurements, any instructions in here. So it is 25, 0.1, X25, like this. And here is C minus 25, 0.1, C minus 25, with or almost. And in here, it was 13, yes, 0.1, X13. Let's hope that it is okay right now, like already. F9 run program. Let's do a fast forward. I already did one cut with G75. Perfect cuts. Last cut. And the last of the last cuts. Well, our program is correct. It is, in here we can see it more clearly. Has the first inclination, has the first cut, has the second cut with the inclination, cut, and the last cut. Well, with this, we finish our practices. I hope you understand my practices and my explanation. Thank you for your attention.